Good morning, student. And today we are going to discuss the next numerical based on the channel and channel matrix. Yesterday हमने numerical discuss किया था जिसमें हमने एक JPM consider किया था, that is joint probability matrix. Today also I am going to take the next numerical and based on the joint probability matrix, and which is already shown on your screen. एंड एक्स्ट्रा डे हमने कुछ पैरामीटर्स को फाइंड किया था, जस्ट लाइक एच एक्स एच वाई, ज्वाइंट एंट्रोपी एच एक्स वाई, कंडीशनल एंट्रोपी एच वाई इज टू एक्स एंड कंडीशनल एंट्रोपी एक्स इज टू वाई, and in mutual information. But in second part there is also one more parameter like rate of data transmission. Then third part, channel capacity, channel efficiency and redundancy. ऑलमोस्ट जो आपके पैरामीटर्स हमने कल डिस्कस किया था, हाउ इट कैन बी कैलकुलेटेड, तो टुडे same procedure we have to follow to calculate all the parameters. And first of all I am going to explain about the matrix, that is the input to the channel consists of the 5 letter, and that x is equal to x1, x2, x3 and x4 and x5. Okay, here this indicate the channel input, means there are the 5 row. Also we can say that the 5 row means 5 probability calculated over, that is in the form of px1, px2, px3 and px4 and px5, and correspondingly column indicates the output. This indicate the output, which can be represented by the 4 letter y1, y2, y3 and y4. And this is the JPM of this channel is given as in the figure. Now we have to calculate the hx, hy and joint entropy and conditional entropy, both conditional entropy and the mutual information. Already कल हमने numerical में discuss किया था how we can be calculated all the parameter, but there are the 4 new parameters are there, just like rate of the data transmission, and the last part is the channel capacity, channel efficiency and redundancy. Okay, again we have to follow the all the rules which are already discussed in the previous lecture, and today we are also follow the same procedure. I am going to explain line by line how to get the all the parameters, just like the number of entropies, and so new parameters like the rate of data transmission, channel capacity, channel efficiency and redundancy. Now next, first of all, here we see the matrix, that is the JPM joint probability matrix, and already discussed in the previous lecture. And first of all we have to calculate the individual probability corresponding to the transmitter and receiver, and corresponding to the transmitter symbol and the receiver symbol. Here the x indicate the transmitter side, means here there are the 5 row, and there are the 5 inputs which are represented by x1, x2, x3, x4 and x5. Already discussed in previous lecture. If we add the row JPM matrix का कोई भी row आप add करेंगे, means if we add all the elements in a row, and we get px1 corresponding to the first row. Similarly here also written x1, then correspondingly if we add this, and we get px2, and after that if we add this row we get px3. If we add this row we get px4, and if we add this row, that is we get probability px5 corresponding to the symbol x5. Okay, already now solution we have to obtain the hx, hy and this one already discussed, and this is the formula, generalized formula to get the pxi. And here considering the m is equal to 4 and n is equal to 5, means this side indicate m is equal to 4, and this side indicate that is n is equal to 5. Okay, And after that already मैंने बोला जैसे we have to calculate the px1. Here we add the element of the first row, like there is the 0.25 here written also, and also and see this this line, see this there is addition of all the element, like 0.25 plus 0 plus 0 plus 0, and we get 0.25. Similarly, for x px2 we see this line, this row that is written already, already elements 0 0.1, 0.3 and 0 0, that is we get 0.4. After that px3 here we can see this one, and after that what will be the value, that is 0 0.05, 0.01, and we get 0.15. And for the px4 comparing these values, and we get px4, and after that okay something left here, means अगर आप इसको ऐड करेंगे means again we get the value 0.15, that is px4 after calculation, and px5 is equal to 0.05. Okay, then all the values are calculated by using the formula. Simply here we use the JPM, and to get the simply get the addition of all the element in the row, and to get the value px1, px2 and px3 and px4. Okay, and after that to obtain the entropy, as we know the formula of the simply the entropy is calculated by using the multiplication of the probability with the information. Now here we are using the formula of the probability, and there are the 5 probability here, that is I ranges from 1 to 5, and there are that is summation, we show the number of terms in the summation, that is here 5. There are the 5 terms corresponding to x1, x2 and x3, x4 and x5. Already all the probabilities are calculated, like the first one is the 0.25, second one is the 0.4, third 0.15 and fourth 0.15, and last one is the 0.05. ऑलरेडी ये आपको सारे दिख रहे होंगे, ये कैलकुलेटेड है, आपको दिख रहा होगा ये 0.25 हो गया, देन 0.4 हो गया, देन 0.15 हो गया, एंड ऑलरेडी okay. Then after calculation by using calculator, we get 2.065 bits per symbol. Now here by using the rows of JPM, and we get the entropy Hx. Now similarly we have to obtain the Hy, and Hy now we have to calculate the number of probabilities corresponding to the receiver side symbol, and that is represented in the form of the py1 py2. तो या तो आप ये फार्मूला यूज कर लें, जो फार्मूला ही मेंशन किया हुआ है, आप ये कर सकते हैं. ओके, या द फार्मूला, एंड आफ्टर दैट व्हाट विल बी, यहाँ पर हम क्या करेंगे, जैसे अभी आपने उसमें रो को ऐड किया था. नाउ इन दैट इफ वी ऐड दीज टर्म वी गेट py1. If you add this one, we get py2. If you add this one, py3. If you add this one, we get py4. Means here we conclude, if we in the JPM matrix, if we add the all the element in a column, and then we get the probability corresponding to the receiver symbol, just like py1, py2 and py3 and py4. Similarly, if we see for the calculating the py1, compare with this line, we get 0.25, the elements are 0.25 plus 0.1 plus 0.0, and we get 0.35. And after that py1 is equal to compare with the second column, like this one, that is 0 plus 0.3, 0.05 plus 0.0, we get the 0.35. Now for py3 compare with this column, we get 0 plus 0 plus 0.01, 0.05, 0.05, we get 0.2. And after that, and for this, compare with this column, simply there is only the one non-zero element, then we get the 0.1. Means here there are the four probability 0.35, 0.35, 0.2 and 0.1. Okay, this is the into a probability. And after that, how will we have to get the probability? Same formula. Here there are the summation j ranges from 1 to 4, means there is a 4 term in the term of in the entropy term. Like the first probability 0.35, second one is a 0.35, and third one is a 0.2, and fourth one is a 0.1. ऑलरेडी हमने यहाँ पे मैंने इंसर्किल किया हुआ है, ये आपको दिख रहा होगा, ये दिख रहा होगा, और ये ओके. Then after calculating by using calculator, and we get this value, that is 1.856 bits per symbol. Now again, and we have to calculate the conditional entropy. Now first of all, we have to calculate the conditional probability. Like this is the formula, and this is the formula, like this one and this one. Okay, now we using the conditional entropy, that is the px to the y, by using the joint entropy formula divided by the individual probability. And similarly this will get this probability can be used to get the h y is to x. Similarly, this formula is used to get the h x is to y. Now this is the table. Here the first column indicate that is ij, means here the element in the JPM which can be represented by the I corresponding to the row and the j corresponding to the column. Here I ranges from 1 to 5, and column ranges from 1 to 4. And then there is in the matrix of the 5 cross 4, then the number of elements in the matrix is equal to 5 into 4 is equal to 20. Now same procedure we have to follow, which were discussed in the last lecture. Now the next column of the for joint entropy, because joint probability, because already there is a use of the joint probability, and which are the elements from the joint probability matrix, and already calculated pxi, that is in the form of the px1, px2, px3 and px4 and px5. And similarly pyj corresponding to the py1, py2, py3 and py4. Now this is the formula to get the conditional probability, that is p axis to y, means this formula, this is the p x is to y, and this column indicate to get the conditional probability p y is to x. If we get the each row, if we get the probability, then simply entropy can be calculated by bits symbol, or bits by bits element are for each element. And then this is used to get the entropy h x y, and this is used to get h y to x. And after that, already discussed in the previous lecture, first of all here we place the value of by taking the element one by one, like in the matrix the elements can be represented by a I j, where I represent the row and j represent the column. Simply here we get the value that 1 comma 1 means first row and first column, 1 comma 2 means first row second column, 1 comma 3 means first row third column, 1 comma 4 means first row fourth column, and 1 comma 5 means and first row and fifth column. Similarly here we are using the matrix. And the finally let us consider an example. If we take the first element, the probability 0.25, and px1 here, because why the here px1, because already an I and j is equal to 1 1, means if we place that here we get px1 y1 px1 and py1 already calculated this value, and simply we have to put all this value, and we get the conditional probability, that is here we get p uh, x1 is to y1, and this is the conditional probability p y1 is to x1. Okay. Similarly, if again change, and then after that we have to calculate the entropy corresponding to this probability, then this is the value 1.21, and finally we get this value is equal to 0, because that is log 1 upon 1 का फॉर्म यहाँ पे आपका आ जा रहा है. And after that that is simply we changing the values of I and j, and means here we get the px1 y2 correspondingly, here the probability px1 and here py2 correspondingly we place the value one by one, and we get the value and calculated like this, and here also like this. Now the table, there are the things, so it cleared that 2.1 means second row first column. Similarly 2.2 means 2 comma 2 means second row second column, second row third column, second row fourth column, third row first column, third row second column, third row third column, third row fourth column, fourth row first column, fourth row second column, fourth row third column, fourth row fourth column, fifth row first column, fifth row second column, fifth row third column, and fifth row fourth column. Means this is the last element of the JPM. Okay. Now here correspondingly this the first element the first element in this indicate the value of I, and the second element in all these set represent J. If we change all the values one by one, then we get the probability, and here correspondingly there is the element of the joint probability already calculated from the JPM. Then by putting the value of I and j, and we get the all the probabilities, that is ranges from px1 to px2 x3 x4 x5. Similarly here also py1 y2 y3 and y5 y4, and this column is used to get the conditional probability p. Here we get p x is to y, and here py is to x, and by using the this correspondingly this entropy can be calculated in this column, and then this entropy converted in this column corresponding to this one. Means so if we to get the final entropy of that is x axis to y, simply if we add all the 20th element of that column, and we get the conditional entropy h of x is to y. Similarly, if you add this column, and we get conditional entropy y is to x. Okay. सिंपली आपको ऐड करना, बिकॉज ऑलरेडी आपने हर सारे इंडिविजुअल प्रोबेबिलिटी का आपने एंट्रोपी को कैलकुलेट किया. सिंपली वी हैव टू ऐड. मैं तो इंडिकेट कर दूं, दिस इज द कॉलम नंबर, ये 1 हो गया, एंड 2 3 4 5 6 and 7, means 6 column. Of the addition of 6 column we get the conditional entropy h x to y, and after that if we add the all the element of the 8th column, and we get the conditional entropy hy is to x. Now to obtain the conditional entropy h x to y, this represents the 7th column, ऑलरेडी बाय यूजिंग द फार्मूला, ये आपके फार्मूला है या फार्मूला ऑफ सिंपली समिंग ऑफ द एलिमेंट इन 7th कॉलम। मैंने आपसे बोला जो आपका टेबल बना हुआ है, टेबल में जो 7th कॉलम, इफ ऐड ऑल द एलिमेंट देन वी गेट दिस वन। आई थिंक सो ये 20 एलिमेंट होंगे, 1 2 3 4 5 6 7 8 9 10 11 12 13, then 14 15 16 17 18 19 and 20. Means there are the 20 element in a previous table. If you take the means here 7th column here and 7th column here, if there is a 20 element, if you add these all these and we get the conditional entropy hx is to y, and its value is 0.08077. Now to obtain conditional entropy hy is to x, here also conditional entropy already जो फॉर्मूला, या तो आप ये फार्मूला ही यूज कर लीजिए या सिंपली आप जो लास्ट जो कॉलम है आप उसके सारे एलिमेंट्स को ऐड कर लीजिए। तो आप जो जीरो है उसको ऐड करने की जरूरत नहीं है, सिंपली हियर वी टेक द नॉन जीरो एलिमेंट, और मीन्स जीरो का मतलब है नहीं, टेक द नॉन जीरो एलिमेंट एंड फाइनली वी गेट द वैल्यू 0.598. ओके, means here we calculate the hx, hy and hx to y and hy is to x. And now we have to calculate one quantity in the next part, that is rate of the data transmission and the mutual information. As we know, the mutual information can be calculated by these two formula. If any one formula can be taken and we get the answer same. Here in this formula, ixi is equal to hx minus hx is to y, and in that formula hy minus hy is to x. If we use any one formula, means all the 4 entropies are calculated, अगर आप कोई भी इसमें से अगर आप calculate कर लेते हैं, then we get the answer. On comparing the answer, here 1.257 and here 1.258, near about its value remains same. If you take the decimal point up to the 2 point decimal, means remains same, means here we are using the any one formula. Now what will the next तो ये आपके सारे नॉन पैरामीटर थे, बट द न्यू पैरामीटर इज द रेट ऑफ डेटा ट्रांसमिशन, जस्ट लाइक dt, and here we are using the formula of the mutual information, you know, information, and multiply by the r, that is small r, already discussed in the unit first, and that is bits per second, and this is the formula of the mutual information, and this whole term can be replaced by the formula of the mutual information, and that is r, and mutual information already calculated 1.257, means या आप 1.258 लिखिए या 1.257 लिखिए, ऑलरेडी कैलकुलेटेड आपके हैं वैल्यूज, हमने वही वैल्यूज प्लेस किया हुआ है, ये आपकी वैल्यूज हो गई, दैट इज 1 पॉइंट, और आर अभी यहाँ पे मेंशन नहीं है, इफ इन द न्यूमेरिकल गिवन द वैल्यू ऑफ आर, तो आप वहाँ से कर सकते हैं। जैसे एक बार मैंने आपको याद होगा, मैंने एक न्यूमेरिकल डिस्कस किया था पहले किसी लेक्चर में, दैट इज यहाँ पे, दैट इन द फर्स्ट यूनिट, आर की जगह हम वहाँ पे सैम्पलिंग थ्योरम का भी यूज करते हैं, वहाँ दिया था आपका मैक्सिमम फ्रीक्वेंसी प्रेजेंट था, एंड वी आर यूजिंग द सैम्पलिंग फ्रीक्वेंसी fs इज इक्वल टू 2 fm एंड वी गेट द fm, तो ऑलरेडी या तो वो सैम्पल्ड के फॉर्म में दिया हो या ऑन द बिहाफ ऑफ सैम्पलिंग थ्योरम के फॉर्म में दिया हो, या आर की वैल्यू जनरलाइज फॉर्म हियर आर नॉट गिवन, तो यहाँ पे जनरलाइज हम आर मांग चलेंगे, आपका आर बिट्स पर सेकेंड है, then overall the data transmission is equal to the 1.257 r bits per second. Okay, now this is the second part, and the last part is about the channel capacity and the channel efficiency and redundancy. Okay, now the channel capacity is given as already discussed in the binary symmetric channel, हमने जो discuss किया था, जो channel capacity आपका 1 minus something conditional entropy hy is to x होता है, हमने वही प्लेस किया हुआ है, एंड देन 1 माइनस ऑलरेडी ये वैल्यूज कैलकुलेटेड है, आई थिंक सो ये आपका यही वैल्यू, हाँ ये आपको वैल्यूज ये दिख रही होगी, वन थिंग मीन्स दिस वैल्यू 0.598, वो वैल्यूज प्लेस ऑन कैलकुलेशन एंड वी गेट 0.042 बिट्स पर सिंबल, दिस इज द कैपेसिटी, and then calculate the channel redundancy and efficiency calculated in the next redundancy, and that is the 1 minus, ये एक फार्मूला है, आपको फार्मूला लर्न करना होगा, and this is the ratio of calculated by using the that is the ratio of the conditional entropy to the source entropy, that is 1 minus hy is to x upon hx, and we place 1 minus values 0.598 and hx 2.065, and finally we get the value 0.7105. That is, or in the percentage form, simply here we have to multiply by the 100 and we get 71.04, and then this is the channel redundancy. And what will be the efficiency? As we know, the efficiency is equal to 1 minus r. Then after that 1 minus 0.714, we get 0.2896, and in percentage form, that is the 28.96. Now there are some new formula which are used to gather all the parameter, like this one about data transmission, and then channel capacity, this formula, redundancy, this formula, and efficiency, this formula. तो ये एक न्यूमेरिकल डिस्कस किया था मैंने. आई थिंक सो आप लोगों के जो चैनल्स के जितने भी न्यूमेरिकल्स हमने डिस्कस कर लिया आपसे कि कैसे कैसे वो न्यूमेरिकल आते हैं. तो बेसिकली आपके जो सेमेस्टर एग्जाम में या यूनिवर्सिटी एग्जाम में आपके न्यूमेरिकल बेसिकली वो चैनल गिवन होता है, आप चैनल मैट्रिक्स बना के आप फाइंड करते हैं, या चैनल मैट्रिक्स दिया हो आप चैनल बना सकते हैं. बहुत सारे तरीके हैं. हमने ये कुछ एक्स्ट्रा न्यूमेरिकल डिस्कस कर लिया, दैट इज हियर वी टेक द मैट्रिक्स JPM और डिस्कस किया हाउ टू गेट ऑल द पैरामीटर. ओके, दिस इज ऑल अबाउट टुडे टॉपिक. ओके, थैंक यू.